Hi everyone, welcome to another video. Today I have a very special guest with me, Swapnil. He graduated from IIT Bombay in 2002, then joined IIMA. He brings together plethora of experiences, information and lot of knowledge about blockchain technology. In this video, we discuss majorly on different consensus mechanism, how they compare with each other, and the proof of trust consensus mechanism, how is it better or worse than other consensus mechanisms which are there in the industry. We also looked at the future of blockchain technologies. You will love this video. We have tried to keep it very simple so that everyone can understand it. So like the video, subscribe to our channel and let's get started.
You know my background broadly, 2002 IIT Bombay, 2004 IIMA. Then worked with BCG for a couple of years, financial services largely. Then did my own startup with 3 other batchmates from IIMA, one of them from also IITB. Sold that to a financial services company, ran their asset management for 5 years. Then worked with a quant hedge fund for about 4 years. And ASQI was started in 2019 as a democratization of investing thought process, smart beta originally, and then blockchain. That's the journey in a nutshell.
First of all, I am super excited to have you today because there are multiple reasons. Like you were in consulting, you were from the same college, you are working in the same domain, and I'm a little bit anxious or nervous, you can say, because you have already published a consensus mechanism which I even feel difficult to understand. You are at a position which I look up to.
No, not at all. So this is mostly we just need to be thinking boldly and imaginatively. And I think we just need to not be under any sort of awe of existing platforms in Web3, because I think most of it is still a prototype, including our own consensus mechanism. This is such a vast field that I think the last word on this will be only uttered 20, 30 years from now. Everything is up for questioning, everything is up for revision. Even Ethereum itself is going through so many changes.
Let's take a step back. How did you move from aerospace engineering to consulting to blockchain? How has that been?
So part of it was accidental, part of it was strategic. So the choice to go to IIMA was driven by my desire to stay in India. And aerospace jobs in India back then at least were quite few. The only choice was to do a PhD somewhere and then work with, say, NASA, Boeing or whatever, if I wanted to stay in aerospace, which I was very keen on. And if not that, then the next love for me was economics. So I said the closest I can get to that is MBA. So I went to IIMA. So I went to IIMA thinking I will go into consulting. So that was strategic. After a couple of years at BCG, I thought, this is all getting too linear. Essentially, now I can see 10 years from now, I'll be a partner, sure. But it's not boring, but it's sort of too straitjacketed. Although it was fun, I just took a plunge in entrepreneurship. That was an accidental thing in the sense that what we chose as our domain was through some macro analysis saying this is the highest growth field, emerging wealth management. And it turned out it was a good choice. We didn't end up staying as entrepreneurs for too long, but that field did explode in the next 15 years, personal finance and wealth management. So that was accidental, but analysis driven. Then from that, I stayed in wealth and asset management for good 10 years. But when the Web3 revolution began, I would call it about 2015. Before that, it was primarily crypto. But the smart contracts and DAOs got me quite excited about this whole aspect of a very different way of doing things, not just incremental changes.
Okay.
So that's how I again pivoted, saying, let's do this major shift. Every 5 years or so, I tend to switch in a big way, 5 or 10 years. This time it was from quant investing to blockchain.
A lot of us, at least in my age, feel an urge to decide where we want to go right now. And seeing you switching fields and trying to still discover where do you want to go in 10, 20 years down the line. So that really tells me that, okay, there is enough time to figure out things. Just go with the flow. Is that correct?
It is. So when I was your age, while going into IIMA, I knew I wanted to do consulting. And out of IIMA, I did get that. And so that was like a dream job. And it seemed like now I'm set, right? So theoretically, my 22-year-old self will say, you're set for next 15, 20 years at least. But within 2 years of that, I realized that life's too rich to get set in just one domain. There are trade-offs, just to be clear. It's not straightforward to switch. You actually give up some, what do I call it, financial gains, some depth. It is every time you switch, it's a risk.
But in consulting, people say that you get to work on different projects and different things. I have been in consulting for 2 years and I also realized that's not true. So what's your view?
That's the part I loved. And as a young professional, nothing better can be done with one's time. I think consulting is the best thing you can do in the first 3-4 years of one's career. Because you get to learn so many things about so many different industries and you're not committing to anything. But what you trade for that breadth is depth. You're jack of all trades at the end of the day, and you're good at this meta skill, which is putting structure to ambiguity and all of that. But beyond a point, that tends to get repetitive. You're doing the same thing for every industry. The industry changes, the client changes, but your approach
more or less remains the same. So jump forward a few years from finance to blockchain. When did you first discover blockchain?
I would say when I realized that you can achieve consensus in a robust manner, in a fraud-proof manner, without coordinating explicitly. To me, that was, and that's again, Bitcoin also does that. That to me was the aha moment where I was watching it from a distance. I didn't study it deeply enough. So I just kept thinking of it as a fringe experiment for quite some time. But when I studied it in depth, I read the white papers, I realized that this is path breaking. This is very different from what we're used to. And this experiment aside, this is harbinger of something major.
And are you with a tech background or a coding experience or something like that?
So that was a good part about my last 4 years with the Quant Hedge Fund, that till 2015, I didn't code too much. Occasionally here and there, some lines of code.
Okay.
In 2006, I did some bit of coding, but very basic. 15 to 19, I did quite serious coding because of, you can't work at a quant hedge fund and not code. So that sort of got me back in touch with Python, and that also gave me the confidence that converting structured thinking into a full-fledged code which works. So I did write a fairly large portion of our current blockchain core engine.
You talked about consensus. We hear a lot about blockchain is solving for Byzantine fault tolerance and these kind of things. In layman terms, what exactly is consensus, and why is it important for a decentralized network?
The consensus is the foundation of decentralization. When we say decentralized, what does it mean? That there is no one source of authority. Okay. So to distinguish it from centralized network, let's take the example of currency notes.
Okay.
Right? A currency note has value because we all believe in RBI, that RBI is a solid institution and it's institutionally perfect and so on.
Central organization which manages the entire flow, demand, supply, and accordingly the flow of currency in the field. So
printing and so on, like keeping authentication and so on. So all of that is RBI's job, and we say we all trust in RBI, and then the note becomes valuable. So we don't need to have consensus on that because it is externally achieved. So somebody says this is a 10 rupee note, and we all visually see that it is indeed seems okay, and that's that. So you and I don't need to agree on that value of the note because that is externally told to us.
How does that change in sense when we remove that central authority and distribute the power among the network participants?
So now let's say there are 50 people trying to deal with each other without any central currency in the picture, right? Now they will have to all agree on something to be used as a mechanism of a unit of transfer. Also, who owns how much, right? So if it's of course it varies by what you call a unit of measure. So gold, for example, for a long period of time in history, gold was the externally imposed consensus of sorts, that it was finite, so it was valuable and so on. But when you think of it in a digital context, there is no gold to speak of. There's no finite resource that we can say, you can't fake it, so that's why it is valuable. That's what gold was. Now, in case we are looking at something which is like an electronic entry, like a ledger of balances, which is what blockchains are, you have to agree that this is the correct ledger. Now, how do we agree on that? That's consensus. If everybody is going to have a say in what that is, without there being a consensus, then I would say I own $1 billion or billion Bitcoins. You will say you own $1 billion Bitcoins, and all that will lose value in no time, because your ledger will say you own billion Bitcoins and I own 10. My ledger will say I own billion and you own 10. And we'll never agree, and then the whole thing will break down. So for this to hold true, we have to have a certain degree of agreement within the group. Whichever group it's using it. So the 50 people are using it, most precise way would be all 50 agree.
Okay.
But that is very prone to just one person saying I don't agree and breaking the whole thing down. So you relax that a bit and say fine, you don't want to have a consensus of 100%. But if 51% people agree that this is the ledger, then that is the ledger.
So you recently launched your own white paper about a consensus mechanism called proof of trust. But there already exists multiple consensus mechanism like proof of work, proof of stake, delegated proof of stake, and etc. etc. Let's first start with proof of work, which is the first one to solve this kind of problem, and quickly make our way towards other consensus and finally to proof of trust. So starting with proof of work. How does that work?
Sure. So proof of work is about saying that I will solve a complex mathematical puzzle which requires resource, and in doing so, I will specify to the rest of the network the transactions that I am using to modify the previous state of the network. So there are some balances and some transactions have been submitted. I will verify them, and in parallel, I'll solve the puzzle, and the accurate valid transactions I'll include along with the solution of the puzzle.
Okay.
That's proof of work. The logic here is the reason you insert the puzzle in the mix is that everybody cannot get the answer at the same time. Somebody will get lucky and get it faster than others. And it's very easy to verify if the puzzle has been solved because the solution is easy to check. They don't need to resolve the puzzle to check.
Why do people say this is very energy consuming, and what are the few terms? Let's also look at few terms like miners, nodes, validators, etc.
Yeah, sure. So in a 50 people network that we talked about, right? All 50 are competing with each other to solve this puzzle. The original view of Satoshi, at least in my assessment, was that people will not bother building specific infrastructure for this. They'll just use their own laptop and say, I'll solve this puzzle and get the outcome and then add transactions to this proof, as I call it, and then send it to the network.
Okay.
And others will verify it. That state does not require excessive energy expenditure. But now imagine the logical next step, that if solving the puzzle is the only way I'm going to get a Bitcoin for free, not by purchasing it, but just for contribution, then I can simply say, I will get a better GPU or a CPU. And then you will say, oh, I'll get even better CPU. And then it will go on, right? It's an arms race of sorts.
Yeah.
Whosoever has because it's a very brute force puzzle. There's no algorithmic elegance to it. That I can be smart and solve it faster. It's just like try 1, try 2, try 3, try 4, like that. So given the brute force nature of the puzzle, at least in Bitcoin context or Ethereum context, there is only an arms race of CPU speed. And that's where people, the whole thing got derailed. It went into this whole, my CPU is bigger than yours sort of logic. And people started to pool their CPUs, and the whole thing went against the whole logic of decentralization. Because if you pool your mining equipment or gear, then you're centralizing the network.
Basically, you are saying that the main motive, the financial incentive which was provided to mine the Bitcoin, again, that became the killer of that particular thing.
Exactly. So it is slowly killing the decentralization spirit of Bitcoin, because you and I can't mine Bitcoin anymore using a laptop. You have to set up a heavy-duty gear, and that then again becomes a logic of only rich people being able to do it. So the whole thought of saying we're decentralizing, putting power in the hands of people, it's all hypocrisy. Most of it is basically that a lot of money to start mining.
So what was the next step taken to reduce this energy crisis thing?
So the logic then is, why should we solve a stupid puzzle? Like the puzzle was put in the picture for a very simple thing. So think of 50 people with 50 ledgers, right?
Okay.
They're all matching at some point of time. One of them,
a ledger is just a set of transactions listed.
I own X, you own Y, she owns Z, so on and so forth. Okay. And in Bitcoin's case, it's very simple. It's just like person, amount, just like that.
Okay.
So that ledger, all of 50 of us have this ledger. At one point of time, we all agree. Now at 51st, block number 3250, some number is next block. At that point, somebody is trying to maliciously change a transaction that happened in 2500th block. Because they paid somebody and they suddenly want to not pay them anymore. So if now they change in their chain, that specific entry, the beauty of blockchain is that they will have to change not just that entry, they have to rehash the entire rest of the chain from that point on. And if you have proof of work as the constraint, that will take so much of time and energy that it will not be worth it, because the rest of the network is already moving forward in the meantime. So you can't maliciously change one entry and catch up with the rest of the network and say, look, this is the valid chain, not yours. So that confusion is impossible to create in Bitcoin. That's why it's very robust.
So how does proof of stake solves this?
So proof of stake is a bit less strong on this front, because it says that why does proof of work work is because it takes 10 minutes or so to get, on an average. Sometimes you get the answer in 10 seconds, sometimes you take 1 hour, but on an average it takes 10 minutes to solve that puzzle. The difficulty of that is set as such. In proof of stake, since you don't take 10 minutes, as in proof of stake then doesn't require that constraint. You don't actually have to solve the actual puzzle and wait for 10 minutes. You actually say that this is my money, I'm locking it in. if I submit a bad block, if I submit a bad transaction, then I'm okay if this stake is slashed. The network punishes me for bad submissions.
Okay.
So that's like
if I behave maliciously.
And so proof of stake then becomes like escrow or guarantee driven approach to submitting blocks. So it's super fast. It consumes no energy at all because I'm not solving any puzzle now. I'm simply saying, here's my stake, and people get selected randomly to mint a block.
So
in proof of work, everybody competes.
Let me just summarize what you said. So in proof of work, there are 50 people with hundreds of ledgers with them, and
50 ledgers. 50 people, 50 ledgers.
Okay, 50 people, 50 ledgers. They want to prove that, okay, they want to include valid transactions in the block. And so all of them compete with their computational power. All of them compete.
Yes.
And one of them who solves the puzzle the fastest, he or she wins and creates a new block. And once he creates a new block, a Bitcoin or any of Ethereum is awarded to them, along with the transaction fees which was there. In proof of stake, these 50 people stake some of the amount, and not everyone is solving for the puzzle. Only one selected fellow is randomly selected fellow is solving for that puzzle.
He's not even solving for a puzzle. Theoretically, or I mean, at least some instances of proof of stake, the most common ones, tendermint and all, you don't solve for anything. You simply say, since you've been selected already by the network, and everybody agrees that you are the person to be selected, there's no need to solve any puzzle.
Okay.
You already put the money at risk by saying, I behave maliciously, I lose that.
But then is that verified with other validators?
Yeah, others verified.
Okay, other 49 people verify that.
Verify what they are doing, so that if he or she submits a bad transaction, they will slash his or her stake and go back to the previous block and say, let's pick the next guy who's supposed to mint it, and so the cycle continues.
Okay.
In proof of work, you lose your chance. You spend 10 minutes to solve that puzzle and you put a stupid transaction in it. You have wasted your chance to earn the Bitcoin. That's why you won't do it. In proof of stake, you have the money that you could lose. That's why you won't do it.
You will lose the collateral.
Correct.
Okay.
Exactly.
And then came a delegated proof of stake.
That's right.
Yeah. So what exactly is that one?
So in a network, so Ethereum, Bitcoin, all of them assume that there is no other currency in the world. And inside that blockchain, that's the only currency. So in that assumption, you essentially say that I have a network of or user base of 1,000 people, but all 1,000 are not nodes. They're not all going to participate in this block minting, verification, etc. Only 100 are nodes. Now the rest of them also still have the money, so as in the coin. So they can say that, look, we will give you the power to vote, as in we can give you stake with which you can bid for the collateral. So it's like saying one person has the equipment and the willingness to be a node, and others simply just hand over the stake to them. And
so say, one has money, one has computational resources to do that thing.
Correct, and bandwidth. And so they just sort of hand it over to him and say, you do it now. And our vote is with you. We trust you. So we'll just sort of go with the fact that we will lose our money if you make some mistake or you behave maliciously, but we don't think you will. So that's that.
So you recently launched a white paper called Proof of Trust, which is sort of based on proof of stake and also includes a very important factor called timestamps with each of the transactions or block formation. So how does that work, and how does that solve the problems with proof of stake?
So there are two problems of proof of stake that we're trying to solve. One is proof of stake allows bad behavior to go unpunished beyond the stake slashing. So I can be a malicious node. Once in a while I can come in, try to do something malicious, and if it doesn't get detected, I go through. But let's say it gets detected, I lose some stake and I continue separately with some anonymous address again and put some other stake. So money is the only way to then purchase the, so to speak, ability to mint the next block.
So the next time that same malicious code comes, it will be treated as a genuine one unless they do something bad.
Correct.
Okay. So there is no history associated. Okay.
Yeah, the memory awareness is missing. Secondly, you can purchase anything with money. You can purchase influence with money. That's the part which is potentially creeping centralization is possible in that. So theoretically, top 20 owners of Ethereum, Ether, can potentially pool their resources together and start to influence the network to their liking. The stake is the only mechanism of determining who gets to do what and which is a valid chain, which is not a valid chain. then the majority can easily maliciously behave and still get away with it.
I think there is a very good analogy with proof of stake. Like the rich gets richer in the network and the poor gets poorer.
That's true.
Okay.
Because if I have large stake, I'll also be having a higher probability of being selected for the next minting, and so I get that reward also. And so it is inherently inegalitarian, and I can also use smart contracts to pool my stake, just like people are pooling their mining rigs in proof of work. In proof of stake also, it's very simple. I can just write 5-6 simple lines of code in a smart contract and say, all of us can put together, we all each own 10%, 5 of us come together own 51%, without handing it over to anyone. It just goes through some smart contracts, and I can still control the network and still own the money. So then it becomes again the plutocracy that we are seeing in the capital markets right now.
So it doesn't solve the decentralization thing. And in proof of trust, you associate some trust factor with each of the nodes. So how does that avoids this from happening? Like we understand that in proof of stake there are large liquidity pools and staking pools where smaller people come, general people come, add their money, and these are run by huge corporations. And
the crucial thing we do is, one, everybody's trust score, even if they have the 50-year history of good behavior on the network, it will be capped. So your trust score cannot exceed 3.0. The minimum is -1, and everything between 0 and 3. So it logarithmically approaches, asymptotically approaches 3.0 as you keep doing better and better submissions all along. So if there are 100 nodes or 1,000 nodes on, let's say, Ethereum, and 1,000 nodes on our chain, in 1,000 nodes of Ethereum, it will matter who owns how much, because then they can pool and control the network. In our chain, the ownership anyway doesn't matter. They just have to put the basic minimum stake for slashing. That's fine. But even if the 1,000, all of them are, or even 100 of them are behaving very well, and they start to have high trust score vis-a-vis others, it starts to taper very quickly. Start with the trust score of 0.01, will gradually go to 3. So even if you keep doing honest submissions, your score will remain 2.99, 2.9999 anyway. It will never exceed 3. So you can't say that I have been doing this for 10 years, so now I'll become the whale. So we're not replacing just stake with time. We're simply saying that it's also asymptotic. So it gets capped. So in steady state, you might have 500, 700, 800 of these nodes, all with a score of 3. But then we all have a system which is fairly democratic, because there are 800 similar people there with equal power to influence the network. So collisions in that is much harder, because to control the network now you have to collude with 400 people, not just 5.
Okay, cool.
So that's far more democratic.
But here is one question. Like, since the stakes are small and anyone can join, if I create, suppose, hundreds of such I stake like 100 times and creating different smart contracts, then how can that be avoided?
So that's where the crucial point of difference comes vis-a-vis Ethereum and other chains, that we are not an anonymous chain. We don't believe in anonymity. Identity awareness, we think, is central to the future of Web3. We think anonymous operations will be a useful subset, which people who care for anonymity will operate in that. The rest of us who don't really care for anonymity but who are more worried about privacy, there are two different things. I want to be private, but I don't want to be anonymous. So in our chain, that's the crucial distinction, that every node is a real person.
So you take something called KYCs for each of the individuals, and
correct. And it could be companies also, but there is a real, natural or legal person whose KYC is submitted, and it is open to verification by the network at any point of time if there is a concern that this is a malicious node. So that's one check against somebody setting up hundreds of nodes, right? Because you get your first node submitted with your own KYC, your PAN, your Aadhaar, whatever. Next, you will go with your friend, and so on and so forth. So for each of them, you'll have to have a real person backing it, because in absence of that, you won't actually have the ability to create a node.
Can you see the identity of a particular wallet?
You can request.
With request.
You can only request. You can request for an audit if there is a requirement from the network.
And who approves that audit?
Audit is the person, the node, it's node's own, prerogative.
So where I'm going is, if a government tomorrow comes and asks for tell me who is this individual. Can you do that?
So no one person controls that access anyway. The node can say, I reject the request of the government to see my data, and that's that. So the government doesn't control our chain anyway. So it doesn't matter. The government can't shut it down. The network itself can request network, meaning the network has well-defined auditors who are decentralized. So there are about 30 to 40 people who are themselves identifiable and sort of trusted nodes, if you will. They can vote on somebody's identity being accurate or not.
Okay.
So they all send a request to this person. This person can say that I don't want to be a node anymore. I just don't want to disclose my identity to anyone, so I'll just walk away. That's fine.
And then Noel will be able to verify who was that person, because he or she holds the private key of that.
Correct. So that's entirely up to them to disclose it. If they disclose it, they don't disclose it to the whole network. And these people also don't download anything. They just view it, confirm that this is a legitimate individual / company. Vote yes. So they say 30 of them are voting, 25 say yes, 5 say no. It goes through, and then there is no question about that person's KYC. And this is not for everyone compulsorily. This is only audit triggers.
This is very interesting. I didn't get this while reading the white paper.
So we didn't put the decentralized audit in that. We just said that your identity is there.
Yeah.
You could authenticate using centralized servers also. So we're talking to a few service providers who will, without downloading your data, authenticate you and just say, yes, this is a valid person. And that's that.
This is very good in the sense that the people who are participating, the network users, they are benefited with their privacy concerns, and the government is benefited in case something bad is happening, they can still have someone who they can hold someone responsible for doing something bad. So this is a very good way of regulation, I think.
Yeah, absolutely. I mean, this is self-regulating and marrying privacy with lack of anonymity. So we don't want to promote terrorist financing and money laundering and all that, which today theoretically can happen on Bitcoin, because when people, they don't want to transfer loads of cash, they'll just transfer to each other Bitcoin, and nobody would be any smarter for that. We want to not engage in those activities. So that's one check. Second check is that the trust score of a new node is 0.01. Okay. So even if there are 1,000 nodes in the system, you come in with 100, you got 100 friends whose KYC you're able to get, but you set up 100 nodes, you're not suddenly going to get 9% power on the network.
Because your trust score is...
the trust scores.
Okay.
And so there are a lot of people with trust scores of say 1, 1.5, 2. So your actual power in the network is going to be close to 1%, not even 0.5% to less or lesser. So you have to carefully build over next several months a good trust score. So if somebody is going through all that effort to just do one malicious activity after 2 years, and that's a lot of effort. So it's not like you can suddenly set up 100 nodes or 500 nodes and say, now I'm going to control this network.
So the probability of someone doing that reduces to such a low extent that it's infeasible and can be said safe.
And all along, so you set up 100 nodes, you're starting to get good scores, right? There are other people, legitimate people joining the network anyway. So by the time you get your decent trust scores, the network itself is 4,000 strong with decentish trust score for others also. So now again, you have to set up your next 400 and get them up the curve as well. So our expectation is that people don't have patience. The hackers don't have that sort of patience. I'll quietly go through all of this.
Hopefully that's true. Hopefully. So you also talk about something very interesting called verifying real world data with proof of trust. So how does that work, and what are the use cases for that?
Oh, so that's actually a very interesting use case we recently came across in agri commodity warehouse receipt tokenization. So a farmer puts their produce in a warehouse, and warehouse receipt they get, we are tokenizing that. Now the question that arises is, are the goods there? If somebody is saying there are 40 metric tons of rice, the token says that, does that correspond to real world rice of 40 metric tons? So for that, a similar decentralized audit exists where anybody can audit that token and say this token means at this warehouse, at this tag, 40 metric tons of a certain commodity is supposed to be there. I'll go and check it. I'm vaguely knowledgeable about how much space 40 metric tons take. So I'll then say that, okay, this is here or not here. And so not one person, it's a collection of people. So 30, 40 people again vote on that, and I go with the majority. So that's one instance of real world assets being verified. through decentralized audit.
How is this different from the Oracle implementation, which is there in other consensus mechanisms?
Oracle is similar. With Oracle, the only thing is that it is digital. What happens with Oracle is that you actually just saying price of Apple stock or price of oil. You're taking it. Now it's available to everyone, but obviously every node querying the network, so querying their own sources of oil price and this thing will obviously create different outcomes. So I can say I'm taking Brent crude, and somebody will say I'm taking WTI. To avoid those confusions, Oracles make it constant and say, look, I'm taking this from these sources, this specific thing, and I'm going to give it to the chain. So that's streamlining of already public information versus in our context, information which doesn't exist currently. Verifiability of fairly micro elements, not things like price of Apple stock.
Just a random thought, I don't know if this is correct or not, but it seems that if there is a KYC linked to each of the validators who is validating whether the data is correct or not, then it puts much higher reliability on the data which has been collected. Is that true?
Correct, absolutely. So the user, now this fact is that if I maliciously go and say that this convert is not there and 29 others are saying it's there, then again my trust score goes down a bit. So we are trying to generalize the trust score idea not only for network participation, but also real life financial transactions. There is a network of say 100 people. They all rate each other, not necessarily everyone to every remaining 99, but I will know 10 people. So I'll rate them in my trustworthiness assessment of theirs.
Okay.
And then they all sort of rate each other, and we can create a trust rank of each individual based on similar to page rank, right, of Google.
Yeah.
So that's one way. Second is, now I have set this up, right, and somebody comes to me to raise funds. Some young person from IIT, let's say. Now
that's me.
So you come to raise funds. Now let's say we know each other now, but you go to raise funds in a circle that people know me in.
Okay.
So they will find out that Raushan is connected to Swapnil with this trust score.
Okay.
So, and I'm connected to them with a trust score, so they know that you're not a stranger. They don't know you directly, but there are 3 or 5 paths between them and you of moderate to high trust level. So they'll say, okay, this is person I can invest in or lend to. And your behavior towards them then will set up a new connection edge in that graph between you and them. And as you continue to behave well, your trust score vis-a-vis them, their trust score vis-a-vis you, will improve.
Okay.
So the next person comes to you. Let's say you go to take a home loan after 5 years. The lender, which could be a bank DAO, doesn't have to be a formal conventional bank. Say a protocol evaluating your credit worthiness. They'll look at your historical transactions on Newrl and they'll say, oh, this person has high trust scores from all these people. Not only that, he has engaged in transactions with these many people and has adhered to contracts, whether repayment or dividend payment or whatever it might be. And so he has a very high trust score.
This is really cool, like a credit score for blockchains.
Correct. I mean, it's a public credit bureau of sorts for an individual, which works in both ways, that for my good behavior, I get rewarded. Even it's a micro good behavior, I get rewarded. Every good thing I do should improve my trustworthiness for the whole network. And every bad thing is that it reduces it. So it's a very strong deterrent against, let me default anyway, who's going to know, right? Like what's the implication? We want to make that also big enough so that people say, let's not do this because everybody will know.
It's like similar to, like, we don't want to default on our credit card payments at any cost. So yeah, just to protect our credit score. It's a similar thing. Yeah.
We're combining two things here. The credits part is the formal version of this. But if you know how Gujarati traders operate informally in, say, Mumbai or Surat or wherever, right? There's a strong community. They hand over loads of money to each other, routinely lend, borrow without any paperwork. But the community is very strong. So if you take one wrong step, you get ostracized from the community because then nobody else will deal with you. Your standing gets damaged.
You have a name in the society and business community. Okay.
So we're formalizing that logic and saying your standing in the network goes down sharply if you do bad thing to even one of them.
And now there are a lot of other consensus mechanisms which are trying to improve the efficiency, like the transaction per second or the decentralization issue, which is very common. So I don't know if you know about Shardium, which has just been launched by Nischal, Wazirix co-founder, that Avalanche is trying to do taking a very different approach. Solana is also using timestamp. The Tinder Mint, which you have reference to, that also uses timestamp. So where is this entire consensus innovation going?
So I think it boils down to what we referred to at the beginning of our talk, right? PBFT, practical Byzantine fall tolerance.
Yeah.
We have to have a consensus mechanism which is resistant to a practical degree of malicious behavior by some subset of the network. It's attack proofing the network. So whichever consensus mechanism, proof of work was the laziest way of doing it, because just throw some computing power at it and it's very robust. So proof of work is super robust but super expensive, and it is now prone to this arms race of the computing power and all.
It was like a stepping stone, but we have come a long way from there.
Quite a bit. And anyway, you don't need to waste so much energy just to achieve consensus, as it is clear from all our work now. I think there will be multiple consensus mechanisms in future. So Solana, for example, for proof of elapsed time, achieves very high transaction throughput. Proof of trust, for example, in our context, achieves a lot of memory awareness and deterrent against actively bad behavior. And it's also resistant to Sybil attacks and 51% attacks.
Yes.
Something else will solve for scalability and so on. So I think depending on the use case, I don't think there is going to be one ring to rule them all, like one chain to rule them all. There'll be different chains for different type of things. I think Solana-like chains will go into the capital markets use cases, where transaction throughput is important, payment use cases. Our sort of work will go into DeFi, so mainstream DeFi, where transaction throughput is not a problem, trust is a problem. You're handling a lot of money and there's a lot of credit risk involved. So where complexity of contracts, complexity of transactions, that's where we score much better over others. We are not competing on transaction speed as such. Shardium is an interesting experiment. We are in fact called Newrl for a specific reason, which is similar to Shardium.
Newrl is the blockchain which works on proof of trust. Developed by ASQI.
So trying to emulate the architecture of human brain. So human brain doesn't process everything at all locations inside, right? So we see sight, it gets processed here. We see smell, it processed somewhere else. Thoughts are processed here, so on and so forth. So in Ethereum, unfortunately, everything is processed everywhere. Every transaction, every block, validation, and so on and so forth.
Okay.
So in Bitcoin, in proof of work, it is processed excessively because everybody is competing. In proof of stake, it is processed one times by the whole network. We want to bring that down to 1 by k, where k is some sort of a constant growing with the network size. So it's always what I call it 10x redundant, not 1000x redundant. So what I mean by that is a transaction validation, a block validation doesn't need to happen 1000 times if there are 1000 nodes. So that's what we also trying to achieve through distributed computing. So long as we randomize things, you can achieve decentralization without forcing the whole network to do it. Sharding in Ethereum 2 or Shardium as a chain are both trying to do this through discrete approach, let's say. So in each 2.0, the shards, 1024 shards within Ethereum will all behave like subsets which are internally consistent, and they coordinate to achieve global consistency.
Okay.
But then everything is processed 1 by 1024 times. So it's already 1000 times more efficient, but that's doing it in a step manner. Shards, like 1000 shards, then there'll be, each shard can have 1000 more shards and so on. Shardium is probably trying to generalize that a little bit more. I don't know enough about it. In Newrl, we're trying to keep it continuous, which is to say, I can bid for a network's time through my transaction fees. And if my transaction is small, I'll say, fine, if 10 nodes verified, that's good enough for me. 10 randomly selected nodes. If a transaction is $1 million transaction, I'll say I want 1000 nodes to verify it. I pay for it accordingly. So that's the missing link. Currently, Ethereum or any other chain, they force you to pay the same amount at the given point of time, irrespective of transaction size. You don't get to choose. You can only say, shall I participate, as in shall I get included in the next block or not? Whether what my transaction is irrelevant. We want to change that logic and say, you You can say I'm a very important transaction, ask the whole network to verify it, or you say mine is a very small transaction, I can deal with the minimum possible.
Okay.
So, and then solve that through distributed computing by creating paths of validation, as we call it. So, more nuance there.
So what I understood is proof of trust includes a lot of things and does two wonderful things. One is although we are compromising on anonymity, but we are doing that in a very secure manner. Yes. And unlocking a lot of great potential with that particular one small compromise. Second, we are improving the efficiency of the entire thing using this neural network sort of optimized computing mechanism. That's, if I can call it that.
Yeah, absolutely. It's distributed computing. Instead of over hyper redundancy, it is distributed and still decentralized.
Okay. This is really cool. But this is for the people who are already in the ecosystem. You are yourself a coder or developer or programmer. But what about the people who are not so familiar with core development side, although they know about, okay, the people who are listening to this and understanding these things, they know about the concepts, but right. Some of them might not be able to develop the code itself. So how do those guys participate in this new financial revolution?
No, I'm so glad you asked that, because one of the things that we're building ourselves, we're calling it a neuron app, as a neuron for the size of the brain, right?
Okay.
Which is meant to enable non-coders to quickly set up DAOs, quickly create trust scores for each other, participate in this network, and also being able to invest, create tokens, invest in tokens, buy and sell them, and so on. I think this stacking will happen as we go along. So initially, when we started Web 1, there was a bunch of things. Everybody had to write HTML code. Mm-hmm. Then came Blogger and other such, WordPress and so on, where they said, basic templates will give you, and then a nice looking page will be created for you on the fly without any codes. Likewise, I think that's starting to happen in Web3 world as well. We are taking up that task on the DAO front. We are creating a lot of DAO templates and smart contract templates, which developers will create and earn royalty for life. And these DAO templates can be used by anyone to set up their own specific DAO. So think of it like a blogger back then for blogs. So that's the toolbox, and you can use that to do blogging without knowing a line of HTML coding. Okay. Likewise, we want to create a stack where DAOs are created by people on the fly without having to know the single line of code, Solidity otherwise.
So you feel that after 5-10 years, blockchain is the thing which will remain in the ecosystem? Is that your belief too?
A collection of interconnected blockchains, I would think.
Okay.
But the trick here is interoperability and not trying to be the one to rule them all.
Okay.
So we already set up bridges with Polygon, Ethereum, etc. because we understand some things are better done there. That's good. So in a bunch of interconnected high quality blockchains, that's what we expect this to become.
You mentioned a very good point. Like there are different functions to different blockchain. Like Google is used for search, even if that's the most famous thing which we use, but for searching people we still use LinkedIn.
Exactly.
So that will still be the case. I also feel the same. There is a lot more which I wanted to discuss, but due to time constraint we have to I won't take much of your time.
No worries. Thank you so much for having me over, and we'll look forward to hearing your thoughts again on all of this.
Yes, let's do this again in a much more depth and technical depth. I hope you enjoyed our conversation.
Yeah, absolutely. Great talking to you.
Thank you so much for coming. That's it, guys. Hope you liked it. Hope you enjoyed it. Hope you gained some really good information. I'll keep bringing these things, and I'm so grateful, thankful to Swapnil for coming on this show. Do like the video, do subscribe to our channel, do check out the proof of trust consensus mechanism white paper and different links in the description, and see you next time. Thank you.